Hello, everyone, and welcome back. Today, we are diving into the world of spam detection using recurrent neural network. Have you ever wondered how your email filters spam? It's all thanks to powerful algorithms like recurrent neural network. They are designed to analyze sequence of data, making them perfect for tasks like identifying spam messages. In today's video, we will explore how recurrent neural networks are trained to automatically flag potential spam messages. Get ready as we uncover the secret of spam detections with recurrent neural network. So with the project setup, you have to download the dataset, okay? So I'll leave the link down below, and when you click on it, you'll be navigated to this page, which is my repo. You can now come and then click on this, which is spam data. It's a CSV file. Once you click on it, you can just come here to download it. Okay. So once you are done downloading it, you have to now save it or paste it in your current working directory. So it has to be in the same working directory as your Jupyter notebook file. Okay. And once you are done with these setups, let's jump into it. All right, so let's start. The first thing to do is to import the necessary libraries. And the libraries we'll be using are NumPy, Pandas, TensorFlow, PyPlot, sequential models, tokenizer, simple RNN, embedding, and then dense. Okay, so I'm just going to run the first cell, then we move on to the next one, and the next one is to load our data set. So I'm just going to create a variable here called, let's say, data, and I'm going to use our pandas to read our CSV. Okay, and then the next thing is to paste the name of our CSV file. So I'm just going to go back to here, our, oops, not open it, I'm just going to copy it. Okay, and then I will now paste it right here and then run it. Great. So now we can take a look at how our data looks. So I'm just going to say data. Good. So as you can see here, we have two categories, which one is the category and then message. Okay. We can also check other stuffs info. Great. So we have 5,572 entries, which are the rows. We have two columns, right? Yeah, so that is some of the information we can view right now. So the next thing is to pre-process our data. Okay, yeah, so we will move on to the pre-processing. And the pre-processing, the first thing we want to do is to as you can see, we have two columns, so we want to separate them, okay, into our feature and then our label. Okay, so I'm just going to create a variable called test, and it's going to be an array, and another one for label. Okay, where we'll be storing our labels, and then I'm just going to write a simple for loop. Okay, so for I and label in enumerate. Okay, oops, enumerate. Okay, here I'm going to pass our data, and then we have a category here, right? So I'm just going to paste that here. Great. And then inside it, we will now uh, append the texts. Okay, so first of all, let's just print the label so that you could see. Okay, so let me run it. So as you can see, the labels we have is ham and then spam. Okay, so what you will be doing is to just append them to the array. So I'm just going to call the text, which is this variable. Okay, so I'm just going to call it right here and then append. Then I'm going to pass in the data, then the message. Okay, so message, I'm just going to paste the message right here. So we'll be appending the message for each of them. Okay, and then for the labels, we want to basically encode them. So the first one will be for, let's say, whenever there is we replace it with 0. And whenever there is spam, is 1. Okay. So I'm just going to write an if statement here. Say if label equals then we will append. So labels dot append 0. Okay. So we append 0. Else we are going to append 1. Okay. So labels dot append 1. Okay. So we are basically encoding, right? So from there we can now say our text down here. So text equals, and then we are going to use numpy dot as array. So we are going to convert it as an array, and then we are going to pass in the text. Okay. Oops. Oh, the text. We are going to do same for our labels as well. So I'm just going to copy everything down here and paste it right below. So I'm just going to copy that. Great. So once you're done, we can run it. Hopefully we don't get any error. Great. So we don't have any error. Let's take a look at how our text looks. So now we expect our text to be in an array. Great. So as you can see, we have an array containing all the text, right? So we can just take a look at the first one, which is go until, right? So, and then we can also look at the label for that. So label for the first one is 0, which means it's right? And we can verify that by taking a look at how the data was. Okay. So indeed we have the first message and then the corresponding category, right? Yeah. So we've been able to split it into those two arrays, right? And then the next thing is to let me okay let me leave some comments down here. So let me create so yeah. So the next thing is to perform tokenization. Okay, that is just basically generating sequence of integers to represent the text or the message. Okay, so let me say tokenization right here. Tokenization. Okay, and we are going to use our tokenizer right here. So I'm just going to copy that, then bring it down here. Okay, and I would like to save it or store it in a variable called, let's say, tokenizer. Okay, and then we are going to use this variable. So tokenizer dot fit on text. Okay, so fit on text, and then we are going to pass in our text array. Okay, and then we are going to now generate the sequence. So sequence equals tokenizer again dot text text to sequence. Okay, wait. So I'm just going to paste our text here. Great. So now we will now run it. Okay, so now let's take a look at how our data has been transformed to. So just run this. Great. So as you can see, it has been now converted to a sequence of integers, right? So the first message, let me get the first message. Okay, so now the first message is not in a sentence form, but in an array of integers, right? So this represents the first message, which was go until blah 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 point, right? Yeah, and so that is the function of the tokenizer. Okay, just to convert them into sequence of integers. Okay, so the next step is to perform padding. Okay, so let me leave a comment here, say padding. Okay, and at this stage what we literally do is Okay, before I explain that one to you, let's look at the sequence again. So I would like us to take note of the length, okay, because they are all not the same. So the first one, the length or the sequence of integers in the first sentence was 20, right? And then the second was 6, okay. And as you can see, they are not the same. So we have to find a way to uniform them, okay, so that they will all have the same length, okay. And that's when the pattern comes in. So we have to now perform pattern. And before we perform the pattern, let me save some variables like max length. And I'll explain it to you in a second. And then here, I would like to use TensorFlow. So TensorFlow dot keras dot preprocess, then dot pad sequence. Okay. And then here I'm just going to pass in the sequences. So okay, let me make it plural. Let me run it again. So I'm just going to copy this and paste it right here. Okay. And then the next thing is to add the maximum length. So maximum length is equal to 500. Okay. So the maximum length is 500, which means the maximum we are trying to pattern it to the length of 500. So let's say, uh, let me create a cell down here. So with this sequence, with the first one, okay, with the first one, what we are going to do is to add zeros. Okay, so we are going to fill the rest of them. Currently it's 20, right? When we check the length, it's 20. Let's check it again. It's 20. So we have to now add 480 zeros to the array. So we are going to append 480 zeros to the array so that it gets to the 500 length. Okay. It can be before or after the actual sequence, right? So that is what you are doing in terms of the pattern. So I'm just going to run the pattern. Oops, what's wrong? I'm coming. I think there should be sequence here before the path sequence. Okay, so sequence dot path sequence. Great. So now let's run it. Yeah, so it's TensorFlow keras preprocessing sequence dot path sequence. Okay. Now once you are done with that, take note of this. Let's now see how the data is. So I'm just going to run this the data, and then I'm interested in the first one. Let's check the length now. Great. See, at first it was 20, but now it's 500. Okay. So that is the job, or that is the reason why we do pattern. So as you can see, it added 480 zeros, and then after that we had our actual integers right here. Okay. So that is pattern. The next thing is to shuffle our data, and then we move on to splitting it into training and testing. Okay. So with the shuffling, let me numpy dot random. Okay. And then dot seed. Then let's say 42. Okay. So I'm doing this one so that anytime I run the code, the same input, I'll get the same input. Okay. It won't change. And then the next thing is to let me just I think this ones I left some comments. Okay. So this one too, let me leave some here. Say shuffle data, the data, something like that. Okay. Yeah. So the next thing is to get the indices. Then I'm going to say numpy dot arrange 2 hours. Then the next thing is to call the data dot shape. Okay, so we want to get the shape of the data. Then numpy dot random again dot shuffle. Okay. Then we are going to pass in the indices. Okay. So we want to shuffle the data so that we will actually distribute all the data points. Okay. Then the next thing is to call the data dot indices. Okay. Mm, then our labels is going to be our labels indices. Okay. Hopefully we don't get any error. So I'm going to run this. Oops. Here we are. We have an error here. So numpy dot arrange. Let me see. Numpy has no. Okay, my bad. Yeah. So the arrow is supposed to be one. Okay. So let's run it. Sorry for that. Okay. So I think now let's take a look at how our data looks. Great. Okay. So obviously now they've been converted to integers, so we can't say much about them, right? So the next thing is to split them into training and testing, right? And I'm quickly going to do that by getting the training sample. Okay. So let's say training samples. Okay. And I want it to be an integer. So when we check the shape of our data, I think it was 5,572. Okay. So I'm going to take that and I'm going to multiply it by 0.8. Okay. So we are using 80% for training. Okay. And then 20% will be for testing. So I'm going to say x train. Oops, my bad. X train is equal to data. And then we are going to, so the first that will be for training. And then y train is going to be equal to labels. Great. And then for x test, it's going to be data, because that's right. And then for y test, it's going to be labels, then training. Okay. Yeah. So we are taking the first 80% for training, right? And then the last 20% for testing. So that's basically what you are doing here. And I'm just going to run it. Okay. Yeah. So now I'm coming. Let's find out the length for this. Okay. So we are having 5,000, 4,457, right? And then let's get a test. Okay. So the length of this test. Right, so when you sum this, you are definitely going to get 5,572. Okay. Yeah. So the next thing is to define our model. Okay. So that one too, I'm just going to save a couple of variables. So the first one is going to be uh, maximum features. Okay. So features, and I'm going to say 10,000 will be fine, and then number of epochs. So epoch, 10 will be fine, and then the batch size, let's use 60. Okay. So now let's define our model using the sequence model we imported. Okay. So back to where we are. So I'm going to paste it right here. And then the next thing is to model.add. So we are going to add embedding. Okay. So embed then, and then with the embedding we are going to pass our maximum features. Okay. And then we are going to pass 32. So the maximum features, it stands for the length of the numeric code that should be assigned to each word. Okay. Okay, so for let's say Go, when you encode it, how many features or how, the encode variable, no, how many length do you want it to be? Okay, so that is what the number of features stands for. And then the next thing is to um, add a layer, so another layer. So the model, we are going to use the simple RNN. Okay, so RNN, and then that one you're going to pass 32 nodes. Okay, so model, and then you're going to add the last layer, which is a dense layer. Okay, and that one only one node. Okay, on one neuron. So activation function we are going to use here is segment. Okay, and once you are done with that, you can go ahead and run it. Okay, if you don't get any error. Okay, yeah. So the next thing is to compile our model, and let's quickly do that. So model.compile. Okay, and then optimizer we are going to be using is RMS prop. Okay, so optimize this one, optimizer going to be RMS prop. Okay, and then the loss you are going to be using is binary cross entropy. So loss binary cross entropy. And then the metrics you'll be monitoring is the accuracy metrics. Okay, so let's say accuracy. Right. And once you are done with this, hopefully it should work. Let me check whether there is no typo. Okay, let's run it. Ah, so positional argument follows. Okay, then yeah, metrics. So it's plural and it's supposed to be in. Great. So now let's run it. Okay, so we've been able to compile our model, and then the next thing is to train our model. Okay, so we're just going to say model.fit. Okay, we are going to pass in our x train and our y train. Okay, and then the number of epochs. So epochs is going to be, we saved it right here, so I'm just going to copy it and paste it here, and then our batch size. So from that one to save it here, so I'm just going to copy it, paste it right here, and then our validation split is going to be 0.2, which is 20%. Okay, so now let's save it in a variable. Okay, so I'm just going to say, let's say history, something like that. History. Great. So I'm going to save it in history, and now I'm going to run this. So now our model is going to start training. So for the first epoch, as you can see, it's training, and we are having the losses and the accuracy, right? So let's wait for it to finish training, and then we'll proceed. All right, so our model is done training. You use 10 epoch, right? So now let's move on to evaluating the model. Okay, just to know the performance of the model. So I'm just going to quickly create, let's say, predict, right? And I'm going to pass in the model dot predict. Okay, and here I'm just going to pass in the x test just to predict it, and then with the accuracy I'm just going to say model dot evaluate. So model dot evaluate, and then I'm going to pass in the x test and then the y test. Okay, so it's going to evaluate it, and here I would like to just print a simple message here and say so we had an accuracy of 93% and our loss was 0.19. Okay, not bad. You can even go ahead and then just let's get some new message. Okay, so new message, and then just quick algorithm. So with new message, we have to so with new message, you have to make it a sequence. Okay, so the sequence of a new message, I just want to name it low. Okay, so here we will have to use our tokenizer again. So let's go back to the preprocessing. So tokenizer, we are going to use the tokenizer to send sequence. So let me count down here, and then I'm going to say tokenizer text to send sequence, right? And I'm going to pass in an array of new message. So I'm just going to pass this. So whatever message we pass, we want to generate the sequence. So the sequence of integers. Okay. And then once you are done, we have to padding it. Okay. So message dot padding. And here we are going to use TensorFlow. Okay. So let me just quickly go back and without wasting my time, just go and copy this whole thing. So copy that back to here. Let me paste it. Oops. Let me paste it right here. Okay. So here we are passing in the sequence. So we're going to copy this and paste it right here. Great. And then the number of length is the same thing. Okay. Great. And then let's make the predictions. Okay. So model dot predict. Okay. And I'm going to pass in the new message that we've passed. And then now once you are done, we can now, let's say, predicted label. Oops. Okay, let me see. So if it's the prediction is greater than 0.5, then it's spam. If it's less, then it's ham. Okay, let's get a message. So let me go back to yeah. Okay. So let's get any spam message. Okay. Let's try this one. I'm just going to copy this whole message. Okay, and then paste it here. And then let's run it and see what's wrong. So print predicted label. Oops, sorry. Need a comma here and run it. Okay, so it's spam, right? Let's try a different one, which is ham. So I'm just going to copy this, which is ham. Again, it's going to go back, and then instead of this, I'm going to replace it with that. Let's run it again. So this one is ham, right? So we've been able to implement the recurrent neural network model, and now our model is able to detect spam and ham messages. Okay, so if a message is spam, just wrote this algorithm to display that the predicted label is ham, and then or the predicted label is spam. Okay, yeah, so I think that is it for this video. Let me just do a quick recap. So the first thing we did was to import the necessary libraries, load our data sets, and we just look at some few information about our data. We now split our data into features and labels. Okay, and they were stored in an array form. And the next thing we did was tokenization. Okay, so we now converted the messages to sequence of integers. Okay, yeah. So after that, we have to now make sure they have the same length. Okay, so we perform padding on them. Okay, and once we're done, we just reshuffle our data. Okay, and after that, we splitted our data into training and testing, and from there we define our model. So here we have embedded layer, right? Embedding layer, and with this one, the feature max was 10,000. Okay, and then we had another layer which is a simple RNN layer with 32 neurons. Okay, and then we have a last one which is a dense layer with one neuron and an activation function of sigmoid. Okay, after that we just compile our model. The optimizer we used was RMNS prop, and then also binary cross entropy for our loss. The metrics we were targeting was the accuracy, right? So after that we trained our model, and from there we evaluated it. Okay, and we had an accuracy of 0.9%, 0.9, which is 93%. And we actually tried to, yeah, display some. So we just write a small algorithm to pass in a new message and then ask the model to predict it. And actually it did predicted it well, right? So I hope you really enjoyed this video. If you did, kindly click on the subscribe button, like this video, share with friends, and see you in the next one. Happy coding.